In this video, we're going to look at standard deviation. So before we jump into that, let's just review really quick what we've learned, some things about stats and analyzing data. We've talked about measures of center. What are some ways that we can measure the center of data? And we have the mean and the median. Okay, and now we've talked about measures of spread. These are values that can tell us something about how far spread out the data is. And so far we have range and the MAD, which is the mean absolute deviation. So we're going to add to our list of measures of spread here with something called the standard deviation. Now, standard deviation is the most commonly used measure of spread. And you may have even seen it if you're reading articles for other classes or any kind of research on data, you may have seen this standard deviation. So like the MAD, the standard deviation is large when the data set is more spread out, and the standard deviation is small when the variability is small. And we're going to learn how to calculate the standard deviation here in this video. The intuition you gained about the MAD also applies to the standard deviation. So standard deviation is sort of an extension of what we did with the MAD. All right, so let's start by calculating this standard deviation. It's easiest just to sort of go through a particular example and see how calculating the standard deviation works, and then we'll list out the steps for doing that. So let's say we've got the travel times from home to school for 5 students. This is our data set. 7 minutes, 9 minutes, 12 minutes, 13 minutes, and 14 minutes. The first thing you need to find when you're calculating the standard deviation is the mean. So let's figure out the mean travel time. I think we should know how to do that, right? So we're going to add up our values and then divide by the number of values in our data set, which in this case is 5. All right, so what do we get when we add this up? Let's see, those add up to 16. If I add that with the 14, if I add this 16 with that 14, that's 30. And then 40, 50, and 5 more is 55. So 55 divided by 5. This is 55 minutes, right? So it's 11 minutes. That's my average. Now the next thing we're going to do is most easily done using a table. So we've provided a table for you here. And what we're going to do for each data value is we're going to calculate the data value minus the mean. So this is kind of like what we did with the MAD, except this will have a positive or negative value. And then we're going to square that value, which is going to basically eliminate the positive or negative situation. And then we'll go from there. Okay, so for each data value, we've got our 7 minutes. I'm not going to write minutes. Okay, we're going to take 7 minus the mean, which was 11. Right, so that's going to give us -4. And then over here, we're going to take that value of -4 and we're going to square it, and we're going to get 16. Okay, I'm going to do one more with you and then have you complete the rest here. So for 9, we're going to take our data value of 9, we're going to subtract it from 11, we get -2. Now what this -2 tells me is that this data value is 2 less than the mean. So the average is 11 minutes, this 9 is 2 minutes under that, right? Okay, then we're going to go over here and we're going to square that, and we're going to get +4. So all these values over here are going to be positive. Just a quick reminder, if you're punching this into your calculator, which I hope you're not, but if you are and you don't use the parentheses, your calculator is going to say -16 because it's not squaring the negative, it's only squaring the 4. If you want your calculator to square the negative, you have to do that, and then it would come out to be positive. Now, like I said, I hope you're not doing that because you know that a negative times a negative is a positive. So there's really no need to punch that in. You could just do 4 times 4. Even if you were doing something difficult like -1.758 squared, I don't put the negative in my calculator when I do that. I know it's I know it's positive. I just punch in 1.758 squared. That's going to give me the same answer, and then I don't have to worry about the negative button. I don't have to worry about the parentheses. Okay, so that's called working smarter, not harder. All right, so what I would like you to do is complete this table and then unpause the video when you're done, and I will have it completed as well. All right, how does this look? So keep in mind, you're always subtracting the mean. We're subtracting 11 from each of these values. This is consistent for each one. And then we're taking our data values over here, right? And we're subtracting those data values. We're subtracting from those data values, okay? And then we're squaring these numbers to get this last column of our table. So now what we're going to do is we're going to compute the average of the squared deviations from the mean. That sounds tough, but basically all we're doing is we are going to compute the average of what's in our last column. Okay, so these values right here, these values here are the squared deviations from the mean. So we're going to compute the average of what's in that last column. So let's do that. So we're going to take the 16, the 4, 1, 4, 9. Those are my values from the last column. We're going to add those up, and we're going to divide by the number of values, which is 5 values. And let's see what we get here. Let's see, 16 plus 4 is 20. And then 1 plus 9 is another 10. That makes 30. So 34 plus the 4 is 34. And that's going to be 6.8. So now, if we're including units here, that's going to be 6.8 minutes squared. Now, why is it minutes squared? Well, let's think about over here. We took our data value, which was in minutes, and subtracted our mean, which was in minutes. So this answer is in minutes. Minutes, minutes, minutes. All right? And then we went over here and we squared that. So we did -4 minutes squared. So this is 16 minutes squared. What the heck is a minute squared? Well, it's not really a real thing, but it's going to motivate what we're going to do next, okay? Minutes squared is not really what we want. So part D, we want to know the minutes. Since the squared deviations are a certain type of measure of distances between the data values and the mean, the average you computed in part C does tell you something about the spread of this data. However, since the units of the average are square minutes, we're going to take the square root of this average to get the measure of spread in minutes, and that's the standard deviation. So the very last step is to take the square root of what we got from the step before. So the square root of 6.8 minutes. Well, we're going to punch the square root of 6.8 into our calculator. Let's see what we get here. 6.8 square root. On this calculator, I have to punch it in that way. Most of your calculators, you hit the square root and then the 6.8. So let's round this to the nearest hundredth. So let's say 2.61. Okay, so 2.61. And then the square root of minutes squared would just be minutes. So 2.61 minutes is what we call our standard deviation. So the steps to compute the standard deviation are listed here. Find the average, all right? Then you're going to make a table and figure out the data value minus the mean squared. Get all those numbers. Then you're going to take the average of these numbers in step 3. And then the last step is to take the square root of whatever you got from step 3. So now again, you know, this kind of computation is very tedious, and so there are lots of websites and computer-generated things that do the standard deviation. You put in your values and ask for the standard deviation, and it just spits it out. But this is how it's doing it. What we want you to really get out of this is this idea that the larger the standard deviation, the more spread out things are. The smaller the standard deviation, the more the data values are clustered together. So with that in mind, let's take a look at question number 2. And it says dot plots for 3 data sets are shown below. Note that the mean of each set is 10. So they're just telling us that. We could put that in our little table here by putting, let's see, where should I put this little triangle? Like here. Okay, for each of these. So they all have the same mean, the same balancing point. Which set has the largest standard deviation? Now, we certainly don't want to go compute this. This would be a lot of work, right? We'd have to find the average and then do the table. For all these values, it would be a lot of work. Which has the smallest? So we want to be able to look at this and decide which has the largest and smallest standard deviations by looking at the spread. Answer these questions without any calculations. Okay, so I want you to pause the video, think about that, and restart it when you have your answers. All right, well, for the smallest standard deviation, we're looking for clustered together, the smallest standard deviation. Certainly, I think what's happening here is very clustered around the mean, and so I think the smallest standard deviation belongs to this guy down here. So let's actually take this and move it down here. I think you have the smaller standard deviation. So the largest standard deviation is going to be where a lot of the data is away from the mean, and I'm seeing that here. A lot of the data values are very far away from the average. Now, this data set, this first one's pretty spread out as well, but it's got a lot of these around 8 and 12, which are only 2 away from the 10. Whereas this one has got a whole bunch of data 4 away from the 10, so that's going to be pretty spread out. So I'm going to say the largest standard deviation is going to come from this middle data set. All right, let's look at number 3. So we have 2 different things listed here, and we want to say which data set would you expect to have the greater standard deviation. So we have to choose from the heights of students in a 5th grade class or the heights of students in a K through 6 elementary school. Which one of those would have the greater standard deviation, the greater spread? You got it? Did you make your choice? Well, if we think about just a 5th grade class, they're all kind of the same age, right? Within a year, probably. Whereas the height of a K through 6, you're going to have kids that are like 6 years old and kids that are whatever. I don't know. How old are 6th graders? 10, 11, 12? I don't know. But they're way more spread out, right? Because the ages are more spread out. So I'm going to say this guy right here. The heights of students in a K through 6 are going to have a greater standard deviation. So what we mean by that is more spread, more variability, not clustered together. All right, let's go to B. Which would you expect to have a greater standard deviation? The prices of cars at a Dave Smith Spokane dealership or the prices of cars at a Mercedes dealership? I don't know much about the price of Mercedes. That's not my driving thing. But I think the idea here is maybe at Dave Smith, there's more than one type of car. Maybe you've got some less expensive cars and some more expensive cars. Like, I think he's got some trucks, which can be expensive, and then maybe some compact cars that are not as expensive. Where at the Mercedes dealership, maybe they're all expensive, so they're kind of clustered around an expensive number. So I'm going to guess the greater standard deviation is going to be at Dave Smith because they've got cars that are more spread out in their price range. Okay, last one. No, we got 2 more. Okay, number 4. Create a data set that has a standard deviation equal to 0. I think I'm going to let you guys think about that one a little bit. How could you get a standard deviation that's greater than or equal to 0? We're going to skip that for now. Let's go to B. I want you to think about that one a little bit. Consider the data set 7, 9, 12, 13, 14. If you add 3 to each data value, you get the new data set 10, 12, 15, 16, 17. What is the mean and the standard deviation of this new data set? So what I would like you to do for that one is I would like you to actually complete that and go through the computation. And I will provide those answers to you so you can check your work. But I want you to do that one on your own. And same thing with number 5 here. Take your time, read through this, think about this situation, and then answer this question as well.